International Conference, Workshop, Seminar, Research. Dihajar Dewantara Award,
SEAMEO Qitep in Science, a place where science education is getting closer to everyday life.
just like the morning sun, the source of life. We were established to be the center of excellence in professional development of teachers and education personnel in science towards the sustainable development in Southeast Asia. Here we are, SEAMEO Qitep in Science. We provide relevant and quality programs in professional development for science teachers and education personnel. We conduct research and development in science education, school management, public policy, and other related fields. We expand and strengthen networking through various resources and information to support our feasibility. We provide data and information in science education as a reference for policymakers. And we improve our resource management to provide excellent services. We commit our values: quality, innovative, togetherness, empowerment, professionalism. Our flagship programs are STEM learning, computational thinking, Southeast Climate Change Education Program, STEM local context. Our annual programs are training, international conference, workshop, seminar, research. Dihajar Dewantara Award,
SEAMEO Qitep in Science, a place where science education is getting closer to everyday life.
just like the morning sun, the source of life. We were established to be the center of excellence in professional development of teachers and education personnel in science towards the sustainable development in Southeast Asia. Here we are, SEAMEO Qitep in Science. We provide relevant and quality programs in professional development for science teachers and education personnel. We conduct research and development in science education, school management, public policy, and other related fields. We expand and strengthen networking through various resources and information to support our feasibility. We provide data and information in science education as a reference for policymakers. And we improve our resource management to provide excellent services. We commit our values: quality, innovative, togetherness, empowerment, professionalism. Our flagship programs are STEAM Learning, Computational Thinking, SEAQIS Climate Change Education Program, STEAM Local Contacts. Our annual programs are Training, International Conference, Workshop, Seminar, Research. Ihajar Dewantara Award,
SEAMEO Qitep in Science, a place where science education is getting closer to everyday life.
just like the morning sun, the source of life. We were established to be the center of excellence in professional development of teachers and education personnel in science towards the sustainable development in Southeast Asia. Here we are, SEAMEO Qitep in Science. We provide relevant and quality programs in professional development for science teachers and education personnel. We conduct research and development in science education, school management, public policy, and other related fields. We expand and strengthen networking through various resources and information to support our feasibility. We provide data and information in science education as a reference for policymakers. And we improve our resource management to provide excellent services. We commit our values: quality, innovative, togetherness, empowerment, professionalism. Our flagship programs are STEAM Learning, Computational Thinking, SEAQIS Climate Change Education Program, STEAM Local Contacts. Our annual programs are Training, International Conference, Workshop, Seminar, Research. Ihajar Dewantara Award,
SEAMEO Qitep in Science, a place where science education is getting closer to everyday life.
just like the morning sun, the source of life. We were established to be the center of excellence in professional development of teachers and education personnel in science towards the sustainable development in Southeast Asia. Here we are, SEAMEO Qitep in Science. We provide relevant and quality programs in professional development for science teachers and education personnel. We conduct research and development in science education, school management, public policy, and other related fields. We expand and strengthen networking through various resources and information to support our feasibility. We provide data and information in science education as a reference for policymakers. And we improve our resource management to provide excellent services. We commit our values: quality, innovative, togetherness, empowerment, professionalism. Our flagship programs are STEM learning, computational thinking, Southeast Climate Change Education Program, STEM local context. Our annual programs are training, international conference, workshop, seminar, research. Ki Hajar Dewantara Award,
SEAMEO Qitep in Science, a place where science education is getting closer to everyday life.
The Honorable Director of SEAMEO Qitep in Science, the Honorable Presenter of this webinar, distinguished webinar participants, ladies and gentlemen. Good afternoon, everyone. Assalamualaikum warahmatullahi wabarakatuh. Welcome to SEAMEO Qitep in Science webinar series entitled Science in the Air. My name is Lintang Ratri Prastika, Human Resources Officer from SEAMEO Qitep in Science. I'll be your moderator for today's webinar. Today's webinar is the 13th series of SEAQIS webinar. This is part of SEAMEO Qitep in Science initiative to provide teachers and education personnel with science concept enhancement through experiment that can be integrated in teaching and learning activities in the classroom. Before we start, please let me inform you our agenda today. First, presentation of SEAMEO color and SEAMEO song. Opening remark from SEAMEO Qitep in Science Director, Dr. Indrawati. Presentation from Mr. Wenchao from Guanxi Science and Technology Museum, China. Question and answer session and closing. Dear participants, let's move to the first agenda, which is the presentation of SEAMEO color and SEAMEO song.
It's time to open our eyes to a bright and promising future. We'll rise to the call of the times and create a stronger tomorrow. Let's start to make a difference, teaching everyone to learn. Through science, health, and technology, we will share our expertise. By promoting knowledge and policies, we can build a better world. We'll achieve our goals through partnership, creating opportunity by working hand in hand. Accomplish all our dreams for a better quality of life is now within our reach.
Next on our agenda is opening remarks by Dr. Indrawati, the Director of SEAMEO Qitep in Science. Dr. Indrawati, the time is yours.
Thank you, Ms. Lintang.
Recording in progress.
Honorable Mr. Wenchao, expert from Guanxi Science and Technology Museum, China, distinguished guests, and all participants of today's webinar. Assalamualaikum warahmatullahi wabarakatuh. A very warm good afternoon. It is a great pleasure for me to welcome all of you at the SEAMEO Qitep in Science webinar. This webinar is part of our webinar series that we conduct to provide a forum for teachers and education personnel with up-to-date knowledge, information, and best practice in education, especially in science education. In today's webinar, we raise a science experiment regarding physics concept in high school. Ladies and gentlemen, as we know, education goals have evolved to emphasize student acquisition of the knowledge and attribute necessary to successfully contribute to the workforce and global economy of the 21st century. The new education standard emphasizes higher and skill, including reasoning, creativity, and open problem solving. Science education, which is considered very critical by many education experts, should come with various innovation to answer the challenges, and of course, physics education as one of important subfield within science education should be delivered effectively and interactively to students. Physics education for the 21st century aims to foster high and reasoning skill and promote deep conceptual understanding. For many years, teachers and other relevant parties related to physics education have developed many teaching methods to help raising student interest in learning physics. In this webinar, we collaborate with Guanxi Science and Technology Museum, China, to share how physics learning activities can be more interactive and give better understanding for students. Guanxi Science and Technology Museum has become our partner since 2019. We have participated in their activities where we learn many new knowledge, insight, and innovation related to science education and science laboratory equipment. Today, we are very lucky to have them in this webinar. I do hope all the participants can learn the basic concept of the air that underlying the physics experiment, so our students can be more interested in learning physics and gain deep understanding on what they learn. Distinguished participants, ladies and gentlemen, to conclude my remark, let me express my sincerest gratitude to Guangxi Science and Technology Museum for their continued cooperation and support to our program. We do hope after this webinar, we can work with you again in other programs in the nearest future. Last but not the least, my gratitude and appreciation are delivered to all participants for participating in this webinar. We wish you a pleasant webinar. For no further delay, SEAQIS webinar, Science in the Air, is officially open. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Dr. Indrawati. Dear participants, before we move to our main agenda, please let me inform you some important guidance regarding this webinar. Today, there will be only one speaker who will share his knowledge and experience about science concept, especially about air. The speaker is Mr. Wenchao from Guanxi Science and Technology Museum, China. He will try to explain some interesting problems through a series of demonstration experiments focusing on the pressure correlation principle of the air. Is the air pressure real? Can you ride a car by blowing? What happens when you are an astronaut walking in space and your spacesuit is broken and you are exposed to the vacuum? Will your body explode? How do household air conditioner cool the air? Can table tennis break through the table tennis racket? And how did you do it? The presenter will have 30 minutes for presentation and we'll have 15 minutes for Q&A session. To ask questions during discussion session, for participants who join this webinar on Zoom, you can use raise hand feature or type your question on the Q&A box on the Zoom application. We will invite one or two selected participants to directly ask questions to the speaker, while other selected questions will be read by moderator. For participants who join this webinar on YouTube, please type your question on YouTube chat box and I will read selected questions from the participants. And to indicate your attendance, for participants who join this webinar on Zoom, you can fill in online attendance form at our course information system. For participants who join this webinar on YouTube, we will provide Google form for the attendance form. The links of the attendance form will be shared at the end of this webinar. So I suggest you keep joining this webinar until the end. Okay, everyone. Now, without further ado, we will move to the speaker's presentation. The speaker is Mr. Wenchao. Good afternoon, Mr. Wei. Mr. Wenchao from Guanxi, China. Before he starts, please allow me to introduce him. Mr. Wenchao.
I'm sorry. Can you hear you? Can you hear me?
Yeah, I can
Okay.
hear you. We can hear you. Okay. Good afternoon, Mr. Wei.
Okay.
Yeah. Before you start, let me introduce you first. Mr. Wei Wenchao,
Thank you.
intermediate title engineer, has been working in Guangxi Science and Technology Museum since 2005 after graduated from physics of Guangxi Normal University. He has been engaged in youth of campus science and technology education for many years, participated in the compilation of several books on science education, and has rich experience in planning and designing science educational activities and popular science exhibit, research, and development. Now, let's start our speaker's presentation. Mr. Wei, the floor is yours.
Okay, thank you. Thank you, Doctor. Thank you, Ms. Moderator, for the introduction. It is my honor to be invited for this webinar. Before we start the experiments, I would like to briefly introduce about my job and why we have this program today. I work in Guangxi Science and Technology Museum. My daily work is mainly administrative affairs, office job in general speaking. But I love creating things in my spare time. I see myself as a maker, and some of my colleagues in other departments work to provide science shows for teenagers in schools and communities, especially in rural schools. It is not easy to make props for show. It might seem that there's not much technical involved, but when we just do the show for the children. But actually, there are a lot of time-consuming detail for even the simplest performance. So they turn to me for help, and I help them for creating props for years. It's like they are the magician on the stage, and I am the mechanic who make props for the magicians. So I'm not really good at acting shows by myself on the stage. But so what I'm going to do to show you today is more about the principle behind these props, rather than just demonstrating the phenomena. All right, ladies and gentlemen, welcome to my workshop virtually. Today, I'm going to talk about one of my favorite topic, air. Using air for show is quite like magic. Air is everywhere, but it's completely invisible. We are immersed in the ocean of air. Our appearances is shaped by air. We can't live without it for the moment. So science shows are very similar to magic show, in my opinion. They are surprising. They all make people wonder why. They all need a lot of technical support to complete a specific phenomena. And usually they begin with a question. So the first question I'm going to ask today, can you rise a car by blowing? Yeah, bloating the air. And before that question, we go to that question, there are a small question I want to ask. When I was young, I was curious about, is the air pressure real? Like the textbook tell us the pressure exists and very high, but why can I feel it? So, and how big is it? So I do some experiment by myself to trying to prove it. All right, let's start with the simplest one. This is a silicon gel plate, and there's a handler fixed on it. Well, for science teacher, you may already know what I'm going to do right now. Yeah, I'm going to use this two metal rod to make a lever. And if I put my weight on this end, will it support it? Will it stand with my weight? Take a guess. That may not be as you might think. Oh, my body weight is about 80 kilogram. Yeah, more than 80 kilogram. And this plate is about 50 by 50 centimeters square, and it has 2,500 square centimeters in area. So in theory, it will be fully support of my weight. So what happened? The trick here is I need to use some water. Play this on the desk before I do this. Why water? Because I need to squeeze out all the air between this plane and a desk. Then I will try it again. Will this stand this time? Yeah, definitely. So what I just said is 2,050 square centimeter in this area. So when we end the level of the sea, it should be about 101.3 K Pascal of the air pressure, atmospheric pressure. So it lines down the place and generate about 1 kilogram per square centimeter of the air pressure. And when it go up to the higher altitude, the air got lesser and smaller the air pressure. So there is about 2.5 tons of pressure on this plane. So there's plenty of pressure to handle my weight and actually quite a lot of people's weight. So when I provide this tools for my colleague, they can do some shows that during the lever, there was a few bunch of children right on this side of the lever. And they were surprisingly about this plane can handle all their weight. All right, so the pressure is real and is quite big. And I will try it another way, like using this plastic shopping bag and using a duct tape to seal it into an airbag. What I'm going to use it for lift some heavy weight is one of this. Yeah, it's about, what is it? Yeah, it's 16 liters of water. So it's about just 16 kilograms of weight. Now what I'm going to do is bloating the air through the straw, and let's see what happens. Now, everybody can see that this is quite easy for me to just bloating some air in it and the water rise up. We can do the math later. Now I'll change one of the paragraphs and we will see what will change. I place it upside down. God, it's heavy. I'll try again. Now let's see what will happen. it's much harder, and the water doesn't seem likely to be raised. So what would just happen? The same person, the same water, the same bag, what changed? I actually do some math before. This big circle is the like the area of the bottom of this barrel, and this smaller one is the head of the barrel. And we do all the math. We know that the bottom, this area, is much larger than the head. So the result, you can do all the math. The result is when we place right on its bottom on the airbag, it generates about 2.5 kilopascal of the air pressure in this side of the barrel. And when it placed upside down, the head will generate about 42 kilopascal, right? We just change how much area the barrel touched the airbag, and it enormously change how much pressure it generates to the airbag. So when I rise it up, just blow it harder. Now I will demonstrate it with this pressure gauge. It can reach out to 0.1 megapascal. So it is just about one atmosphere. Yes, and it's about 100 kilopascal. So what I'm going to do is blow it with my mouth and try my best to move a little this little pointer. I don't know if you can. Yes, the camera can catch me right here. Okay. How much was that? I can't see it. Can anybody tell me how much was that? Yeah, if I saw it correctly, it's about 10 to 12, 1, 2, 3, 4, 5, 6 or 7 of this pointer will get it. So I estimated it will be 10 to 12 kilopascal. So it is generated by my lung, and so theoretically I can generate about just a little under the 10 kilopascal. So this number is right above the 3.5, but it's way below the 52. So that is why. And when we can do an experiment small, we can definitely make it bigger. I already tried to raise a car with airbag already, and I recorded. So because it's not easy to make a car down to this lab, so I will play it on the video. Can everybody see it? Right, okay. So I used a industrial vacuum cleaner. The advance we're using this industrial vacuum cleaner, its inlet and outlet is quite a tube. It's just a tube, so we can attach to other things easily. The vacuum cleaner we use in our house, usually the outlet was just to some filter, so it is not easy to attach to anything else. All right, now we can see it on the video. This is a car SUV, about 2 ton, 2 turns. And we play a big airbag about 3.3 by 3 meters in square. But this is real time. We're not editing, not erase some minutes. Before we really do that, we need to examine carefully about the bottom of the SUV to check if there are any sharp and anything like needle which will punch or cut the airbag. This big airbag we just used the duct tape and some plastic to make it that size. It is not pre-made in the factory, so there is a lot of leaking. Yeah, believe me, they're leaking everywhere. So when we pumping the air into the airbag, I have to constantly check where is the leaking. Now it's already gone about 1 minute or 2 minutes already. Now we can see the airbag is fully support the bottom, the stomach of the SUV and the front wheel because the motor. All right, let's see, the front wheel is already raised. The rear wheel is very high in the air. And there are a lot of funny sounds in the side because there are a lot of small holes leaking and make many different frequencies of the sounds of whistling. Before we rise up the car, of course, we did some math. And the all right, we can stop the video. Okay. This vehicle is about 4.5 meters long, 1.8 meters wide, and the airbag whose support is right about this area. And we calculated it's about 5.4 square meter. And the weight of the car is 2 tons. So the result is the car would generate about 3.6 kilopascal to the airbag. Remember what I generate with my lung? Yes, about 10 kilopascal. That means I can definitely using my mouth to blow air in the air and rise the SUV we just saw. Yeah, actually, if you look carefully at the number, it's 3.6. This one is 3.5. 2 tons of SUV generate the pressure just a little above this water barrel placed on the desk. That's quite amazing. Okay, this for the big airbag for rising the car. We can definitely do that. And we also can do using the airbag for rising many people. And it's quite funny sometimes. I will show you another video. This is another day I do this experiment right on this lab. And I invited 4 of my colleagues. This gentleman are definitely overweight. Just 4 of them already generate 340 kilograms of weight. So I use the same vacuum cleaner as the air pump to a smaller airbag. Now let's see what will happen. When the airbag expands, it will become a shade of rod. Yes, it's round. So it's kind of difficult to stay in one place. As you place on very heavy weights on it, it will roll from side to side. So when we do this show in schools, we could invite about 10 or more children to step on the airbag, a bigger airbag, of course. Then when the air blows in, they will quickly know the air pressure is real and it's really big, because just in less than 1 minute, then the airbag just expand and roll everybody out of it. All right, that's it about for my first question. And next question I want to ask about is, so the air pressure is real, but why couldn't I feel it? Because this square is 2.5 tons. That's a lot of weight. Why can't I feel it at all? So before we go to that question, there is a demonstration I can show you. This what will happen as you are an astronaut just doing the spacewalking, and your spacesuit just suddenly break, you explode into the vacuum. So will your body explode? Well, as we're doing this demonstration for science teachers, so I assume many of them already know the answer. The answer is no, you won't be explode. Your body won't explode, but it will be extremely painful. Why is that? Because our body are made of solid organisms and liquids. Solids and liquids doesn't change much under pressure change. Organics, on the other hand, are elastic. So what I'm going to use is one of this vacuum box. And the first one I will gonna put it in is a cup of blood. Relax, there's nobody's blood. It's just some water, sugar, and some edible pigment. And it's still warm, just to simulate our body temperature. Now, what I'm going to do is place this cup into the box, close it, and use a vacuum pump to suck out all the air. And we could look carefully using the camera. Yes, right, okay, that's good. Look, using the camera to watch, to observe what will happen to this blood. There are going to be some noisy. Okay, the camera just lift a little bit right here. Okay, right here. So this is another pressure gauge. It is for the negative pressure. It is now pointing to the 0. So it sets we are in one atmosphere of pressure. So when the air inside the box decrease, the pointer will turn to the left. And when it point to the minus 0.1, that means it's completely vacuum. So we could watch the same time when the pressure decrease and what will happen to the cup. All right, all sealed. Open up. You ready? Nothing changed? Point A, it will be 14 as the minus 0 point is 10. It is down to the 0.08. So it is already just less than 10% of normal one atmosphere. And it's keep going down, keep going down. It is now only 5%. I don't know if you can see it. Just there are just a little tiny bubble, air bubble on the surface of the water. And we could see some moisture on the cup. Oh, it's gonna boil. It's gonna boil. It is now about 4%. Oh, it's boiling. It's boiling. Now we can turn off the pump. Now we can turn on the pump. So what we saw is your blood just suddenly went into a deep space. There's no air at all. The water inside your blood will boil. Yeah, that's all about it. And we could see this experiment. We can see two ways. One way is decrease. Another way is increase. Now we put the air back in. There are a very tiny water drop fully paint on inner side of this box. Why is that? So I leave this question to all the science teacher. Some of your you might already know the answer. So we could try another thing, the flash. Oh, it's still warm. Remember that the water can boil under a very lower pressure. And what will happen if we just place in the flash? This is about 1 pound, 500 grams. I'm not sure how much is that. This is a piece of beef, and it's also my dinner. Now we place in it, place in the box, and we're trying to make it into the deep space. That better? Okay. That might seem better. All right. Ready? In 3, 2, 1. Look carefully. It looks like nothing changed, right? The air pressure is dropped down to 7, 6. We'll keep going. It's dropped down to 5%. 5% of one hemisphere. Keep going. Keep going. Well, I'm not sure if you guys can observe what happened to this piece of meat. Wow, I could place some ruler on the background so we can sort it more obviously. It dropped down to 3%. Okay, I think. Oh, let's keep going. So I don't know if you guys can see it on the video clearly, but the volume of these meats on my side of my wheel is already changed a little bit. It expand a little bit. It's not that much. It's not that much. It's not like exploding things. It's like when a it's been pressed and just slowly expand, release all the pressure inside it. Now the air pressure is dropped down to 2% of one hemisphere. When we look at this diagram, we could find it. It's, where is it? It is way beyond. That kind of height is just estimated about 100 kilometers above the sea of level. Okay, I think the air pressure is not going to go down. Let's just start the pump. As I say, we can observe this experience two ways. One is decrease the air pressure. Two is increase. Now watch carefully. Got that? So our body tissues is composed of various cells, and cells are composed of various molecules. These molecules are connecting to each other by chemical bonds and close together under the pressure of air pressure. So the answer of my second question is no, your body won't explode, but will die extremely painful. And our body is shaped by the air pressure. So every single molecule in our body is in a balanced state under an atmosphere pressure. So you cannot feel it unless it's changed. Okay. Now let's go to the third question I'm going to ask today is how the household air conditioner cooling the air. In my age, when I was young, there is not much air conditioner could be seen around my house, my community. So when I grew up, there are a lot more air conditioner being installed around the community. I always wonder why, how could the machine can cool down the air by this bumping? What did they do? So I do an experiment to find it out by myself. First, I'm going to a small one. Let's play this pump down and use it later. This is kind of jet can. The science teacher familiar with the football games may ring a bell of this. When your like your muscle damage or you broke your skin, you just use it to cool down the local skin. That will reduce your pain and reduce the edema. And let's see it. It's quite cool. Now this is a temperature meter. I don't know if you can see it. Zoom in, please. Good. More. Okay. It's about what is it? 25.8 degrees Celsius is of the room temperature. And this is the sensor. When I hold it in my hand, if it rise slowly, sorry, its refresh rate is quite low. It should be going on, yeah, 28. Flash, please. Yeah, 28.4. Okay, you got the idea. So when I use this can to spread some fog on it, let's see what will happen. 8.2. Yeah, that fast. Actually, we could go down further. Can anybody see that? Right. Minus 4.8. Okay, that's it. So this kind of principle is called the adiabatic expansion. And when we could do this small one, we definitely can do it bigger. The fire extinguisher. This fire extinguisher is carbon dioxide. This is fully loaded by the pure carbon dioxide. There are actually two kinds of fire extinguisher using the carbon dioxide. One is this one it contains the pure carbon dioxide, and the pressure is so high it stays in the liquid state. And the other type is using the dry powder. And we use the compressed carbon dioxide to just spread out the powder and cover the surface of the burning things. So this one. And what I'm going to do is using carbon dioxide to generate dry ice. Yeah, dry ice, not the ice. What I'm going to do is exactly the same thing. I'm using this. If I spread this to the air, it will go into the air. You can't see much of the ice or the dry ice. So what I'm going to do is using this breathable sac to cover the tube. Hold it tight. Hand protection. Ear protection. It's going to be loud. So alert. You can turn down a little bit your earphone, the volume. Okay. And ready? In 3, 2, 1. Not much. Ooh, there's a little bit something solid. Again. Ooh. That's just a little. All right. Now let's see what we got. Oh, I still need the gloves. What we got in here, it should be the dry ice. Oh, okay. Now just let's see on the table. Okay, yeah. Now, if we dip it into the water, right? That's how we make the fog on the stage. So when we call give him some ice, dried ice to make some fog, that's what it means. Isn't that beautiful? Actually, there's still more on it. I think we can save it for the next experiment. Don't waste it. Ooh. Okay. So our next experiments will do more lower temperature. Before we go to that, I could just explain more about the Adiabatic expansion. And this is why we use the compress to liquefy the air. This is when people doing back in 19th centuries. Yes. Or what? Yes. We're just going to show this one. Sorry. So what I do just now is when the amount of high pressure gas from a chamber going into environment there is relatively lower temperature, it will expand, its volume will expand extremely rapidly, and it is too soon for it to absorb the heat from surrounding. So its temperature will go down rapidly. Then if we get all the gas back, compress it again, and do all this thing again, now we can move the heat from one place to another place. So that is how actually the compressed cooling principle work. Say this is the air conditioner of in your house. The gas compressed by this compressor, it is high pressure and high temperature. It goes to the heat sink, and when using the air outside your room to cool it down, take away the heat. And when it's still high pressure but lower temperature, it goes through a valve. Then it expand the volume. The temperature will drop down remarkably. Then this cool, low pressure, low temperature gas go to this side of heat sink, which is like in your room, the place you want to cool down, and absorb the heat inside room. Then they go back to the compress. So you're trying to continue this revolution. The work you have to give out is the compressing, which you can easily use, do it from the water power or the steam power, like back into 19th century, or we can use in the gasoline, using the electricity to do it. So this is the principle. We move the heat from one side to another side, and move the heat from your room outside your room. And that's maybe why our Earth's getting warmer and warmer. That's one of the reasons. And this is what we do exactly when people do in 19th century. They compress the air, and lose some heat, go down to the expander, to the valve, and continuously this revolution goes round and round and round and round. So the air inside, the temperature is keep going, so still until the gas liquefied. So this is one of the most important machine when the human industry. Using this kind of machine, we can produce massive amounts of pure gas, like we were just using the nitrogen, oxygen, and other gas. All right, let's play with some gas. Now we are going to use another cool thing, which is liquid nitrogen. Oh, it's cool. Yeah, my assistant, Anna, will give me this several kind of colored bottle air balloon, which contains different kinds of air inside. This one is CO2. This one is oxygen. And this one is regular air. And I keep another balloon inside this ball. If I don't put the things above it, if it rise up, is the hydrogen. So these are four balloon. What I'm going to do is pour a lot of liquid nitrogen in this barrel, and I will sink this four balloon into it one by one. So you might take a guess. What will happen to this balloon? I'll do it, and you will guess it. First one, we're going to CO2. Carefully. Don't go anywhere, just stay there. liquid nitrogen. Hand protection. All right. There's a lot of liquid nitrogen boiling in there. All right. Now I'm going to drop one. This one is CO2. Now take a guess. What will happen? Would it shrink or not? Would it shrink a little bit? Or it would just like going to nothing? You ready? In 3, 2, 1. It almost go to nothing, right? It all turns into the dry ice. Okay. What's your guess? Now what's next? The air. What will happen? Take a guess. Is just the regular air? Will it shrink? Will it shrink a little bit? Or will it just shrink into like nothing, like the CO2? What's your guess? Now 3, 2, 1. Ah, there's still something in there. Still some air in there, right? What is your guess? Oh. It go back quickly. Now, let's go to the oxygen. Is that oxygen? Right, oxygen. Take a guess. What will happen? Ready? 3, 2, 1. Almost nothing, but it goes back quickly, just like the CO2. Oh, don't go. Stay there. Okay. Oh, it's leaking. The balloon is broke. Now the last one is the hydrogen. Take a guess. What will happen? Ready? 3, 2, 1. Not much. Not much, and it go back quickly. So what really just happened? Let's not waste this load of liquid nitrogen. I'm gonna put it back. As some of the science teacher might recall, yes, different kinds of gas have different kind of a different boiling point. The liquid nitrogen we're using right here is about is normally about 200 to 210 degrees Celsius under zero, below zero. So you can see it in this diagram. The boiling point of the nitrogen is 195.8 degrees under zero. So as I said, it's about 200. Ooh, the hydrogen goes up. So the temperature is cooling enough to make the CO2, the oxygen, to quickly go down to the liquefied point. So that's what we saw just there. The air is the mixture. Most lovely is the nitrogen. 78%, about yes, 70 or a little more percent of nitrogen, and 19% of oxygen, a little argon, and some other kind of gas. So the air is also most of it can be liquefied by using the liquid nitrogen. All right, let's play something other things. Yes, please, Anna. What's this? The helium. Yes. A helium one. Where's the hexafluoride? Right. Yes. This is my assistant Anna. Hi, Anna.
Hi.
Yeah, she'll do this experiment with me, and this balloon is filled with the helium, right?
Yes.
Helium, right?
Yes.
I need the that one. So hexafluoride. Yeah, when we talk about helium, you might already know what I'm going to do. I'm going to suck in the helium and you will go to the sulfur hexafluoride, right?
Okay.
We'll explain later when we after we done it. Ready?
Ladies and gentlemen. Yeah, it's the beautiful day, right? It's a beautiful day. Oh, as I do the sulfur hexafluoride, I always say that, of course, it's strange. It's definitely strange. Yeah, that's funny. Ladies and gentlemen, there's no reason I doing this with Anna. It's just for funny, right?
Thank you.
Thank you. Thank you, Anna. Every time we do this on the stage, it is funny. Everyone laughed. So it's a little pity I can't hear you. Anyone behind this camera laughed? Okay, no? Right. So after we're done playing with this gas, now we go to the last question I'm going to ask today. Can a ping pong ball break through the ping pong ball racket? The answer, of course. Camera, please. Yeah, okay. The answer, of course, we can do it, and we do it multiple times. We using different kinds of ping pong balls and different kinds of rackets to trying to break it off. And like this one is too much. Yeah, this one's too much. This one is not enough. And this one is perfect. So, of course, we can do it. The real question is how? Before we go to that part, I could do it, begin with a Chinese traditional medical means. cupping. Yeah, I believe the audience from Asia highly possible already seen this one as a medical therapy. So, what I'm going to do is using this 75% disinfect alcohol, as the people usually do. No, I'm not drinking it. I use the swab to apply it in the interface of this jar, then light it. The camera, please. Yeah. Okay. Okay. So this is a silica gel place, like I used just now, is quite similar to our skin and flesh. So after a few seconds, we can see it. The jar is sucking to this skin. Now, what happened? There were when we observed the process of cupping, two things happened. One is that the alcohol inside the jar burns and some gas disappear, resulting the reduction of the internal gas and a decrease of the pressure. And the second, the air outside pressed the skin and flesh into the jar to occupy space as to maintain the balance of the pressure. So this is the same thing what I'm going to do next. Yes, as we can do it smaller, we definitely can do it bigger. Using the air pressure, I could broke this barrel easily. Oh, before I broke it, so I have to prove it is a strong water barrel. Yeah, can't break it at all. So what I'm going to do is light it up. Oh, maybe that's not enough. Oh, cool, that's enough. Sometimes I fail. Now, that is my power of one hand, just for jokes. It is the pressure of the air atmosphere. Okay, what I just demonstrating is when the alcohol burning out all the oxygen inside, then the volume decrease and air pressure crush down. So when I will do this on this tube, camera please, wider, wider, wider. Yes. This tube is have a just slightly bigger inner diameter than the ping pong ball. So it can goes from one side to other side freely. Then we use two very thin of mylar to seal up the two ends. Then I will go into the vacuum pump. Where is it? All right. Seal up. Okay. Then I will go use the pump to suck the air out. Yeah, some of you might see that the ping pong ball already go to the outlet of the tube. Okay. You guys cannot see it, but I already look at the pressure gauge. There is almost nothing, no air inside this tube. what I'm going to do is I'm going to use something to punch one end of this tube to break the mylar. And the ping pong ball, hopefully the ping pong ball will go out from this end and hit this can, aluminum can. Now, it will be loud. Cover your ear. Ready? And 3, 2, 1. Ooh, that's a little bit stronger than I thought. Where's the ball? Can you find the ball? No? No, we can't find the ball. Yeah, that one is stronger than before. What happened? Okay. Can you guys zoom in, please? Right. The ball just breaks through the can and goes somewhere I couldn't find it. So, what happened? When the air being sucked out of this tube, the ping pong ball can go freely, right? Inside this tube. And when I punch this side of mylar, the air rush in. And because the inner diameter is just slightly bigger than a ball, so the air push the ball just go through the tube as it go inside the tube. Then this thing goes quickly, just matter of a few milliseconds. Then we do some tests already. When the ping pong ball go out from this side, the velocity will high up to about 67, if I recall right, 67 meters per second. That's about 210 kilometers per hour. That's fast. So it could broke a aluminum can. Then there's another tube right here. Just now I used the vacuum. And if we use some air pressure, high air pressure, so this one is a little different. This right here is a tank, can store some high pressure air. And this a hand valve, I can turn it on and off. So I already placed a golf ball inside. Are you in? Right. Okay. Please. Yeah. It will be a little danger. Now I can use this manual pump to pressing one atmosphere above our atmosphere. Then I will try to push a little bit the golf ball. Maybe next time I could place another camera here so you can see the gout. Always short of camera. It's get a little bit hotter when the pressure get higher. All right. All right. That's it. One atmosphere. I think we need something to punch. How about this one? It already suffered, so let it suffer more. Okay, this one it shouldn't be loud. What I'm going to do is push the valve quickly, and the air will rush out, pulling the golf ball out from this end. Ready? 3, 2, 1. Woo! Are you hurt? No? Okay, right. another punch, but there's not something obviously more damage. So what I'm just do is using the high pressure, the higher pressure from one side compared to the other side. So the high pressure will push the ball outside from the other end. So I just push the pound to get in about 1 atmosphere. Of course, I can do a lot more than 2 or 3 or more. So the energy, momentum energy will tremendously increase. So that's what I'm going to do with the ping pong ball. We're combining this one and this one into the final experiment we're going to do today. This is the tank. This is vacuum tube. Right? As we're doing this experiment, we fail a lot of time. Ladies and gentlemen, this is the science experiments. We failure often, successful sometimes. So honestly, I definitely not sure about this one, even before we successfully built a bunch of this racket. What I'm going to do is the same thing. Suck out the air from this tube and place about 6 or 7 times of atmosphere in this tank until this place 5 right 5 layer of the 5 layer sheaf of the mylar until it break. And now let's pray. Okay. Vacuum is okay. Now the pressure. Okay, I'm going to turn on the air pump. Might be some noise. And everybody in this room, please cover your ear. Cover your ear. One, 2, 3, 4, 4, 5, 6, 7. Oh, I'm sorry. The pressure's leaking. Oh no. Ladies and gentlemen, you are watching a live show and we are fail in the live show right now. What happened? Oh, there's some leaking. Sorry, just 1 minute. Yes. As I say, fail often, successful sometimes. Now I'm releasing the pressure. Then we will and strengthen it. Then we will do it again. High pressure of gas tank is always dangerous. So make sure there's no condensed high pressure gas inside. Okay, I will check it. Okay, I will fill up maybe 2 or 3 atmosphere. 3 times atmosphere. Let's see anything leaking. Okay. All right, seems good. Now I'll try again. I will try it again. The second time. Ready? Five. Anybody hurt? Anybody hurt? No? Great. Wow. This time is the most perfect punch I ever made, ladies and gentlemen. I could call that a success. And I could use some plug right now. Next time maybe we could do it live, real life, I mean. Right. So what just happened? What just happened? Yeah. The crucial part is we need to empty this tube, because the ping pong ball is very very light. It's just about 2 grams on weight. So if we don't suck out all the air, as the high pressure pushing it go through that tube, it will generate a lot of friction and heat, then slow down the ball. So it goes out there, there's nothing terrible. Okay, so, and besides the high pressure, we still use some tricky things as we do this air tank. What I want to say, adiabatic expansion, the high pressure almost zero velocity of gas. When we go through a nozzle, the airflow will go fast, go fast. And then as the airflow go into the expansion tube, it will go faster and faster and faster. So this is how you get the high pressure and low velocity of air into a low pressure and high velocity of air. And we're using the force to push this side. This shade look familiar, right? Yes, it is the rocket engine. Rocket engine write this principle. As the fuel burning inside this burning chamber, and go through this nozzle and expand in this expansion tube, then it goes faster, even faster than the speed. All right, I think that's all I'm going to show you today, if I didn't forget anything. All right, ladies and gentlemen, that's all for today's show. Thank you very much.
Thank you very much, Mr. Wei, for your presentation and demonstration. That was so fun and interesting. Hopefully it gives a better understanding about basic concept of the air and its phenomenon in our life. The best part for me is the last part, maybe, the table tennis demonstration. It was so interesting to see that the air pressure can make the table tennis has a huge momentum, so it can so it can break the table tennis racket. That was so amazing, sorry. Okay, dear participants, next we will have a question and answer session. We have about 15 minutes for discussion. Maybe for the participants on Zoom, anyone who want to ask directly to Mr. Wei, you can raise your hand. No one. So maybe I will read the question, Mr. Wei, from Ting, Mr. or Miss Ting. The question is, when teacher doing an experiment in a lab or classroom, they supposed to relate the experiment with a concept, theory, principle, and it must come along with a control set for the comparison purpose. And by referring to the experiment demonstrated, could you relate it to any SDG which is relevant besides anticipate in STEM curriculum? Please, Mr. Wei, you can answer the question.
I'm sorry. I quite not follow up the last part. Could you repeat
Okay.
that?
Yeah. Could you relate the demonstration, the experiment demonstrated, with any SDGs which is relevant beside, which is relevant in STEM curriculum?
Okay.
In learning and activity curriculum.
Okay. What? Okay. I'm sorry, but I'm trying to understand the question.
Okay,
So
okay.
you are asking, as yes, I understand there are certain things that when teacher do the experiment on the classroom for the children, and as we doing it on the museum or the outdoor or somewhere else besides the classroom, what will be improved, get I don't know how to put this. So what I'm going to do to do the experiment besides for fun, right? Is that what you mean?
No, maybe for what Mr. or Miss Ting means is, could you relate the demonstration, the experiment that you demonstrated with some curriculum in school?
Okay, we do this show. Actually, my colleague do the show most of the time. They do the show just for the children in the school. Like they were holding some kind of big activities. Then it will, as the show on the stage for a few hundreds of the children at the same time.
Okay. Okay, thank you. Miss or Mr. Ting, could you or any other response for you, or it's enough? Okay, are you still here? Okay. Okay, thank you, Mr. Wei. Mr. Ting, say thank you for you. Say thanks for you. Okay, maybe for the next question, we have also some questions from other participants on YouTube. The question is from Mr. or Miss Samnat Chemi and Mr. or Miss Limwell Naldoza. They have the same question. The question is, do you have the worksheet for the experiments? And could you share it to the participants on this webinar? You get it? Three.
Who do you mean do this experiment first time or just for this webinar or regular days? What's that question?
For the experiment that you showed to us.
Yes.
Yeah.
Yes.
Do you have the worksheet or student sheet activity about that?
Oh, no. Actually,
Okay.
There's few things I just developed for just this webinar. And yes, some of it is showed for the first time. Not there's no children already seen that before. So maybe we could carry out the other day for the children. And in China, we do the experiments and we try to record it, most of it, and edit it into a short video and
Okay.
place it on the social media or the short video app like the Douyin, like something like that. TikTok, yeah, maybe you heard that. And we edit it into the short video, much shorter version, so we can spread it out through the internet.
Okay, thank you very much, Mr. Wei. There's no worksheet for this experiment, but you can, dear participants, you can find another example of the experiment from Mr. Wei to show it into your classroom to be more information to understanding the science concept based science concept in the experiment. Okay, the next question, Mr. Wei,
Yes.
from Mr. Rahmat Ramalan. He asks, how does the working mechanism through the drawing or flow diagrams for the result of this experiment? Maybe he means how the flow diagrams for this experiment. What does it look like?
Yeah. Well, how do I put this? Actually, I do the most of the mechanical job for my spare time. As I mentioned before, my job is mainly the office job. So, well, let's say it. The different kinds of museum, they have different composed of the employees. Some of the museum, like the China Science Technology Museum, they are much larger. They have more than, they are 400 to 500 employees. So they have much more expertise. Like the magician I mentioned before, they can do a lot of props for the employees just do the show, and some of them just do many work just doing the props. Rather than Guanxi Science and Technology, we just had 100 and little more 40. So I didn't actually do it in my full-time job, and I do all this stuff in my spare time, which some of my colleagues, they're also interested in this kind of stuff and help the colleague with doing shows in a full-time job. So I think I could answer that as right now, we just had 2 or 3 of us doing this kind of mechanical things. And that's for now.
Okay, thank you, Mr. Wei. Another question, Mr. Wei, from Tuti Utami. Can teacher use something simple in our environment to do this air pressure experiment, or it must use the laboratory appearance only?
Actually, well, when things evolve to the vacuum, you need to get a vacuum pump, right? So this cannot be any more simpler. So, but my opinions, when you can get just a vacuum pump, this one is not much weight and not very expensive, but it's very powerful. As you can see, it can suck out this big of box in just minutes to nearly the vacuum. So the simplest way I could think about is just one tube, like this one, maybe shorter. I tried it some before. I can show you. This one. Yeah. This one is just about 1 meters long, but it can also punch a ping pong ball through a can, aluminum can. So that's the simplest way I could think about, like if you want to replicate this experiment using the ping pong ball. And if you want to really do that, just breaking the racket, I don't think there's more simpler things I can you could apply that. So yes, you have to do it in the lab in a control situation. But besides the ping pong ball, you can also do a lot of things, right? Like another ball, another things, like a feather. Yes, a feather in the tube. That we can see how fast it could accelerate just for that one atmosphere. So just one pump. Yeah, we can do a lot more than. And besides, for the high pressure, another one to show you, like this one. Yeah, this one is much similar. This is quite similar to the how to say that, the potato gun, right? That something very American or North American things, where people using this PVC pipe to build up some sort of air gun to shoot out a potato. Yeah, this is a much smaller tank, and you can use a manual pump, small one, just fill the air pressure and punch something like the ping pong ball, also some balls. Yes, yeah, that's what I think. If that answer.
Yeah. Thank you, Mr. Wei, for your answer and clear explanation. Okay, ladies and gentlemen, due to the time limitation, maybe this is the last question for our speaker. Thank you so much, Mr. Wei, for sharing your insight on concept of the air and demonstration the experiments.
Thank you. Thank you all.
Yeah. Now we have finished all of today's presentation. From the speaker's presentation, we could learn that air is the important part of the basic matter in the world. There are a lot of phenomena related to air that can be observed and being understood during learning and teaching activities at school. The basic concept of the air phenomena can be more understandable if we observe and analyze it in experiment activity. These experiments can be done using simple instruments around us or advanced instrument in science and technology laboratory, as Mr. Wei showed us in his presentation. And the basic concept of the air is the air pressure or atmospheric pressure. Air pressure is generated by a collection and extrusion of gas molecules with each other. For the same amount of air, it depends on the size of its phase it took and its own temperature. The object pressure depends on its mass and the surface area, and the same object under different pressure, the volume will change. Every molecule of human body is balanced with the atmospheric pressure environment. The basic concept which underlying the work principle of air conditioner is adiabatic expansion. Different kind of gas has different boiling point and density, and generally, students can learn this basic concept of the air in the physics or chemistry class with gas flow topic. Dear participants, that's all the conclusion of our today's webinar. Before we end this webinar, I would like to invite all the participants to create an account at our course information system at course.qitepinscience.org to get access to our upcoming programs. And then I would like to inform you about the attendance form and evaluation form. We have shared the link to access the attendance form and evaluation form on the chat box. Please fill in the attendance form and webinar evaluation form, as it is the requirement for you to get the A certificate. We will send the certificate to your email by 7 working days at the latest. Finally, on behalf of SEAMEO Qitep in Science, I would like to extend our gratitude for the speaker, Mr. Wenchao, for your sharing. And thank you for all participants for joining this webinar. We wish you well, be safe, and have a good day. Assalamualaikum warahmatullahi wabarakatuh. Thank you, everyone.
Thank you, everyone. I'm sorry, is it over?
Yes,
Oh, okay.
it's over. Thank you, Mr. Wei.
Right. Yeah, one word to Zuhat. Zuhat, are you still there?
Hello, Wendy. Yes, I'm here.
Yeah.
Thank you very much for the presentation.
Yeah. Do you know that when you say that it is for the science teacher, I was immediately regret. Yes, because you know that if you just do it for children, right? As long as there's something explodes, there's some color changes, they're always happy. But for the teacher, you have to more accuracy and much more the principle, which I'm really not good at. So it feels like I was the dessert, and you made me as a main course. So that's a lot of pressure, to be honest. But I'm still glad. You invited me for that.
The show runs very well. I think I read the comments and I think they like it.
Okay. Oh, there's comment, right?
Yes, of course.
Okay. So maybe you can you can send me the link after. Can I see it?
Yes, you can read it in the chat box.
Chat box. Okay, that's right. Okay, that's all. Thank you all.
Thank you very much, Wendy. Maybe next time we will do something else.
Are we still on?
Yes.
Oh no. No.
Hello, Wendy.
Yeah. That's all. Goodbye.
Goodbye.